Welcome to Week 12 Advanced Wastewater Treatment Using Biological Systems. Firstly, I will introduce about the conventional system, followed by the advanced uh, moving bed biofilm reactor system. So we know sewage, or we call it as wastewater, can come from domestic and also industrial area. There are many sources causing water pollution in water bodies such as river, pond, and ocean. But among the pollution sources, STP or sewage treatment plant are the major source of pollution point. Sewage means wastewater. This is a glance of the technology involved in treating wastewater, showing the statistic by IWK. It is a company, Indah Water Consortium in Malaysia, in charge of treating sewage in Malaysia. About 42% use mechanized plants, and followed by communal septic tank. Actually, increasingly this is phasing out because most of the new residential area have the centralized sewage will go to the centralized mechanized plant. Ideally, we would like to produce the standard A of the effluent, the wastewater discharge after treatment. However, majority of the water treated only fulfill standard B in Malaysia. So today we will learn a range of the conventional sewage treatment plant which suffer of huge size, unpleasant smell especially during raining season, difficult to maintain. Also, there's a lot of the sludge bulking issue, meaning that the sludge volume is very large as compared to more advanced STP, which has the concept of compact, high efficiency, and environmental friendly. However, it also involves some costs for buying the media or microbial inoculant to enhance the efficiency. So after we gone through some conventional reactor, we will learn about this advanced aerobic biofilm combined reactor as a case study for advanced STP. At the end of this course, you should be able to describe the major parameter used to characterize the influent and effluent of the wastewater to fulfill Malaysian water quality standard, especially for wastewater discharge. You should be able to describe the major unit operation involved in the primary, secondary, and tertiary treatment for wastewater. However, most of the treatment plant for domestic only involve primary and secondary. However, for industry wastewater, which involve higher pollutant of ammonia or phosphorus, will require tertiary, which is a more advanced treatment. Thirdly, you should be able to describe and compare the process efficiency when comparing more advanced biofilm reactor as compared to the conventional STP. So here show the summary of conventional activated sludge treatment, aerated lagoon, extended aeration, and other more advanced such as rotating biological compactor, BAF, MBR or MBBR, so you can read the advantages and disadvantages. I will to show you, give you a better idea on how this treatments looks like. So this is conventional activated sludge. Usually they are series of round pond like this. This clarifier to remove the pollutant, the soluble one or the solid one from the wastewater. The lagoon is quite similar to conventional activated sludge. You make use of a large lagoon and just rely on the aeration to reduce the pollutant. For extended aeration, this has a more compact design, more space saving than the conventional activated sludge. However, it is more energy intensive to enhance the oxygen supply and removing the sludge at a higher rate. Another one, this is biological aerated filter, is considered as advanced. For extended aeration, this is still considered as a conventional, as they are based on the concept of the conventional design. So this will give you some idea on the plant layout of a conventional activated sludge wastewater treatment plant. The influent, you can see all the notation here. The influent of wastewater come inside the plant, going through the screen, and then the grid. 12 is blower building. Blower means the compressor to supply air to support the aeration tank in number 7. Number 6 is primary sedimentation. Firstly, this will sediment the large solid, and the sludge will be disposed as a desludging process. Then the liquid will come into the tank with aeration, bubbling. Then it will go into the second stage of sedimentations, and number 8 is secondary sedimentation. So all this will take a long time because the aeration is quite minimum and a large space as a whole. And then chlorination to disinfectant the clarified water, and finally 19 discharge. As compared to extended aeration, the design is much more simplified. However, it has a larger aeration tank to facilitate more efficient sludge pump out. A lot of the sludge will be pumped into the drying bed for disposal. Some of the sludge will be returned to the sedimentation, to the aeration tank. This process is to make use of the biomass in the sludge, in the returning sludge, which is rich in microbes that can degrade pollutant in the aeration tank. And this process is continuous. The water clarified will enter another sedimentation tank here for supernatant, meaning that clarified liquid will be pumped for chlorination and then discharge. So as you can see, the design is more compact as compared to conventional. This diagram will give you a better idea. There is a block diagram here representing this 3D diagram to give you an idea. Screen, it looks like this. Mainly it is to remove those large waste such as plastic, bottle, paper, and so on. It's called screen. Then it will go through a comminutor, which is to break large stone into a smaller pieces. For grit removal, you can see the grit, those small pieces of sand and stones. So comminutor is to break any larger stone into a smaller sand pieces for easier discharge. Yeah? So this is very standard screen to grid. Yeah, and then it will come to the primary clarifier. Yeah, it looks like this, the structure and the outlook of the clarifier, where there is an arm that will keep on rotating to do the kind of centrifugal forces to sediment the sludge, to facilitate sludge treatment and removal. The supernatant will go into aeration tank. This is a series of large tank supplied with air compressor, and then basically you need to understand primary treatment is to remove solid from liquid up to primary clarifier. Whatever starting from the aeration tank is considered as secondary treatment because this is focusing on the degradation of soluble pollutants such as nitrogen and phosphorus-based pollutant. Then it will enter into the secondary clarifier. Again, the sludge will be removed. Part of the sludge rich in biomass will be recycled back to the aeration tank, and the clarified water from the secondary clarifier will be disinfected by chlorine before discharge. Okay, as taking a closer look at the grit remover, the outlook looks like this, and going through that kind of barrier will discharge the small stone and sand-like material called grit. Okay, there is a good video showing the process of aerated aeration to give you an idea how this is happening. Going into more advanced treatments such as biological aerated filter, conventionally this involves the orange layer of the filter comprised of media bed such as polymer. We call it biostyrene. It looks like the small particle of polystyrene. Why is it called bio? Because the naturally occurring microbes such as nitrifying bacteria will eat the pollutant such as nitrogen or phosphorus based pollutant as their food, so they will thrive and produce a lot of biomass, and the biomass will attach or absorb on the media bed, and this become a filter so that the water coming out from this filter will be clarified and for discharge. So this is how it looks like, the VF. Another advanced, considered quite advanced treatment as compared to the conventional method. It looks like you just need a big tank filled with lots of the carrier. Looks like this. Yeah, it is designed to create a lot of surface area for the attachment of the biomass, so that after attached it looks the ugly like this. It looks like a mooncake to me. And all this will be floating using some compressed air, sponging through the bottom, will float all these carrier and actively attach a lot of the biomass after degrading the pollutant, so that the water coming out from this moving bed bioreactor, the water will be substantially clarified. So this is a diagram showing the sewage inlet going through the screen. So now you can imagine how the screen. Equalization tank is basically to dilute the wastewater to a suitable concentration, either concentrate or dilution, to be suitably treated by the MBBR tank, the moving bed. Blower is to charge the air, to sparge the air for biological degradation. The green one is the biomedia, the media that I showed you just now, the packing. Filling, they have different name. We call it media or filling or packings. So it go into the secondary settling tank to further remove, intensify the removal of soluble pollutant. The sludge will be moved into sludge collection tank. The clarified wastewater will go into pre-filtration before further polishing and final clean up using PSF, pressure sand filter. Is a thick layer of sand to further remove those pollutant. And then activated carbon, for sand is to remove those small solid, very fine solid, and activated carbon filter is to further purify the soluble contaminant. Dosal is chlorinization, and finally it will be quite ready for discharge. For the sludge, it will be going through filter press. I show you how it looks like, the filtration unit to remove the liquid. This will go back to the equalization tank for recycling, and the solids will be used as a compost or disposed. If it is high in heavy metal, it cannot be used as a compost. So this is the standard, Malaysian standard, governed under the Environmental Quality Act of 1974, showing if the water is to be discharged to river, standard A or B, the value. When the value is lower, meaning that it is more stringent. Usually BOD in front is about few hundred. We have to clarify to less than 50 for discharge. COD can be few thousand depending on domestic or industry waste. Ammonia, this is soluble solids, suspended solid. Nitrate as a nitrogenous pollutant. Total phosphorus. If the water is to be discharged to the stagnant water body like pond to avoid the boom of the algae, this has to be monitored as compared to if flow to river. The microalgae booming is not so serious. If there is a lot of phosphorus, promoting the microalgae booming, it can cause the fish to die out of because due to lack of oxygen. Another standard is known as National Water Quality Standard. Usually we concern about the productions of type 2, class 2B, especially at the industrial scale or residential scale, because it can be used for recreational use with body contact, for example, for vehicle cleaning, flushing, with possibility of body contact. It has to be class 2B. But for irrigation, class 4 would be enough. The higher the value means the requirement is not so stringent. Okay. So you need to be able to elaborate what is primary treatment. As I told you, this is mainly removing solid from the water. For secondary treatment is to remove the soluble pollutant like nitrogen and phosphorus based pollutant. We can use BAF, which is based on biofiltration, or we can use EA, the aeration, extended aeration tank based on aeration concept to remove the pollutant, or we can use lagoon for the oxidation pond. If the ammonia content is quite high after the primary and secondary treatment, which will require more advanced and efficient tertiary wastewater to remove, such as the MBBR, or in this study we will talk more about a novel reactor called ABCR based on MBS, with the technologies of activated carbons and plastic carrier. So just now I explained about how MBBR work and how BAF work. For ABCR, this is a novel reactor designed by a professor from Shanghai. He improved the BAF design into a reactor called BioX because he does not just use simply any polymer base. He does not use just any carrier filter based on the polymer, but the carrier is based on immobilized microbe. And for MBBR, the moving bed carrier, also there is a novel carrier called MBS. Yeah. So in comparison, the BAF conventional only use granular filling, but in the BioX we will use brush-like filling. The main advantage is that it doesn't need the back flushing to remove the extra layer of the biomass. For the MBBR, introductions of MBS is because we use embedded bacteria in the media, and the aeration also use very fine bubble. So this is the design from the raw water into the microfilter. This is the primary treatment, replacing grid, screen and grid from the BioX 1234 reactor will involve secondary treatment, and this entire system is known as ABCR. Okay. So this is the schematic diagram of the BioX reactor using the brush-like carrier, and the MBS system using the activated carbon embedded in the polymer carrier. And only this system will not need any aeration, that's why the DO level, dissolved oxygen level, is quite low. But typically for any aerated tank, the DO level is sustained at 2 to 4 milligram of dissolved oxygen per liter. Sometimes there is a duration where low oxygen is supplied, is to allow anaerobic microbe to scavenge to eat quickly, to degrade faster on some of the difficult pollutant. Yeah, so meaning that combination of aerobic and anaerobic condition is a good strategy to fully degrade a wide range of the pollutant. This explains why there is one tank the DO level is low without any aeration. So this is how the BioX reactor looks like. It uses the kind of brush, like a milk water brush, to install it in a series where the water flow vigorously through the series of the chamber. In between there is this oxygen charging mixer installed in between the chamber to sparge a lot of the oxygen through the aerobic zone and the anaerobic zone, with less oxygen sparging here, so that aerobic and anaerobic conditions can be controlled by controlling the sparging of the oxygen. As for the MBS, it looks like this. This is a fingers, the palm, small bits of the MBS media using the polymer polyurethane gel with the activated carbon particle embedded inside. Each of these bit is about 2 to 4 mm to be moving like a moving bed of a biofilm. This is called biofilm because the pollutant will enter into the gel and degraded by the microbe embedded inside. So inside the pore of the activated carbon, there is a specialized, specially isolated bacterium. This is patented, trade secret. A kind of bacterium embedded inside, seen under 50,000 magnification. Okay, so this system, this kind of polymer is quite cheap. So, but the activated carbon and the microbe inoculation will be the main cause. When we suspend in this moving bed, it will efficiently treat the water. So when we analyze the effect of the biological degradation, there will be a range of the tests. Usually we use the American Public Health Association, APHA. There is a series of tests that at least 7 of these tests are compulsory to monitor the quality to ensure it achieves the standard of each country will have a different minimum value, but the standard value I have just shown you just now, standard A or standard B or class 1 to class 4, like that. Okay, this is the parameter I have mentioned also on the slide. If we use the novel ABCR using the MBS media, we can see that at about more than 10-hour retention time. Retention times, hydraulic retention times means how long the sewage water is kept within the reactor. Okay, so we can see the holding time is needed is about 10 hours for all the pollutant to achieve below the standard. So if the pollutant is lower than 60, this will achieve standard. But if the retention time is 5 hours, the yellow color, it is over the standard A. So if the company want to use the water recycle to boil the boiler, the water must be standard A because it will have low mineral, avoid the deposit of the mineral on the boiler, which will reduce energy efficiency. Okay, that's why standard A is of interest here. So in short, the hydraulic retention time of 10 hours is an impressive outcome from this study done by one of my master students. Imagine if you use conventional sewage activated sludge, the first technology, it will require 30 days. But if you use this kind of advanced system, the time needed is about less than 1 day. But we have to buy the media, prepared for tank in series. This will also cost, provide the cost to this advanced technology. So as a conclusions, you after this talk, you should have a clearer idea on comparing conventional wastewater treatment plant and the advanced technology such as MBBR, ABCR, which has a combination of BAF and MBBR, and also you should be able to articulate primary, secondary, and tertiary treatment. In fact, all this advanced technology involving embedded microbe technology, MBBR and BAF, is considered tertiary treatments. Okay. Okay, I hope you will discuss among yourself or post questions in the coming lecture. Thank you for your attention.